Okay, I think we can start and let people joining while I'm making my very short introduction about SCAR. So I welcome everybody tonight for this new webinar for the geoscience, the SCAR Geoscience webinar series. As usual, I just give a very short overview about what SCAR is and what's the geoscience and its action and expert groups. And then I leave the floor to this time to Mauro and Stefano for illustrating what's ANTPAS is. So I'm going to share my screen. Can you see it? Matilde, do you see my monitor?
Yes, perfect.
Okay. Okay, so for those who don't know what SCAR is the Scientific Committee on Antarctic Research, and which is a thematic organization of the International Science Council. And SCAR is charged with initiating and developing and coordinating high-quality international scientific research in the Antarctic region and the Southern Ocean, and also provides independent scientific advice to the Antarctic Treaty meetings, and other organizations like the IPCC, on all issues concerning science and conservation and management of Antarctica and the Southern Ocean. SCAR is quite old. The first meeting was in 1958 after the International Geophysical Year. And since then has been stimulating and growing thousands of scientists who has shared a common objective, basically, which is to carry out Antarctic science. SCAR does it through the organization of events like the Open Science Conference, many workshops, thematic meetings, and also release fellowships and awards, especially to junior scientists, but also for seniors, for visiting other laboratories. She managed the library and data bank, trying to make guideline for policy and data sharing. And it operates through three main science groups, which is geoscience, life science, and physical science. And I'll just tell you something more about this. The main governance is from the SCAR Executive Committee, which is responsible for working with the Secretariat and the members of the community to execute decisions that are taken by the delegates, approved by the delegates. And basically it comprises a president, which is Gary Wilson from New Zealand now, and four vice presidents, which are from on the left of Gary. Gary is the one in the center. Actually, I can use the pointer. Okay. This is Gary Wilson in the center from New Zealand. And then Carlotta Scuzia from Spain, Professor Nakamura from Japan, Marcelo Leppe from Chile, and Burcu Olsoy from Turkey. And then Chandrika Nath here, that's the executive director. And then is supported by the secretariat, Owen, Joanna, Angard, and Agnes. They are all in UK. And they are appointed for 4 years, and they are elected by the SCAR delegates. And there is also the former president, which is also appointed for 2 more years, overlapping with the new president. For the geoscience, the present leadership is basically Jesus Galindo from Spain, Naresh Pan from India, myself from Italy, I'm in the secretariat, and Matilde Giulia Ferrante, she's a junior scientist. She got a fellowship for supporting us in managing all the business of the geoscience group. So the geoscience in particular includes several action and expert groups, which has a term of 8 years generally. They have a specific target they can achieve, and they have a small budget they use for organizing meetings, for helping young scientists to attend conferences, but also to produce maps or other products for outreach and dissemination. And you'll know more about this from Mauro and Stefano. The life science and physical science are also have action expert group specific on life science and physical science. The one on geoscience, we have heard something from each of them in the past webinars, but for example, ANTMAP is dealing with a collection of Antarctic digital magnetic data to produce maps like this. IPSCO, the International Bathymetric Chart of the Southern Ocean, they're collecting bathymetric data and they're compiling the bathymetry of the Southern Ocean. Other action group like AntVolc is collecting information about the Antarctic volcanism on land and also offshore. And then we also have other action groups like RINGS, which are not only geoscience, but they are cross-disciplinary because they are supported by the other science group as well. And it's a group which is interested in highlighting the bathymetry and the topography at the grounding zone all along the perimeter of the Antarctic ice sheet. Today's seminar is about ANTPAS, Antarctic Permafrost and Soil. You can find more information in the SCAR portal, and we'll listen from Mauro and Stefano what ANTPAS does and what's the target. Just as last slide to show what's next. So this is the webinar list. We have listened most of them already from July through to now. Today is ANTPAS. Next, we will have PRAMSO, Paleoclimatic Records from Antarctic Margin and the Southern Ocean on November 11. And then on November 13, the Geological Heritage and Geoconservation. We changed the time. Initially, it was scheduled at 3 p.m., but now it's 6 p.m. So if you note the time, you have to change it. And then there is another one on December the 3rd, which is about the Antarctic Seismic Data Library System that was previously scheduled last week, but we had some technical issues, so we had to postpone it to December the 3rd. Once it's confirmed, I'll put it in the SCAR portal within this list. So, okay, if there is no question, I can leave the floor to Mauro and Stefano.
Okay, thank you, Laura. Now I share the screen.
Yeah, while you prepare your screen, I just say that now we have about 30 minutes of presentation from Mauro and Stefano, and at the end, anyone who wants to ask any question, we can stay for a bit longer. And of course, you can always write us if you want to know more. You will find all the contacts in the web, in the SCAR Geoscience portal. And we welcome everybody who is interested to join and to contribute.
So, can you see my screen?
Yes.
Okay. So thank you very much and welcome to everybody. So this evening I and Stefano, we will explain what ANTPAS is and what we are going on since almost 20 years ago. So just some briefs information about the background because ANTPAS is probably a peculiar expert group in SCAR because it was born as an action group within the International Permafrost Association, and after that we started a liaison in 2000 with the SCAR. Since 4 years ago, 4 years later, we established the ANTPAS as a working group in IPA and expert group in the SCAR with the same people and the same structure. We had just a brief period between 1998 and 2004 in which the group was more larger because it included all the southern hemisphere and not only the Antarctica. So the aims that we have are mainly the construction of a common repository for permafrost and soils data, but also to coordinate all the studies regarding permafrost and soils in the ice-free areas. Because one of the data more important for permafrost are the temperature recorded in boreholes. What we have already done in reality, it was to produce a protocol for monitoring the permafrost temperature in Antarctica that is slightly different respect to what we are doing also in the Arctic. And obviously, we are trying to do also, and in some cases we did some common project, not only on the monitoring of the permafrost conditions, but also on the impacts of the permafrost on the Antarctic infrastructures and on ecosystems. So since the very beginning, we did many sessions, thematic sessions, both in the SCAR Open Science Conference and the International Permafrost Association conference. In addition, we also did in 2017 a specific workshop that was held in Varese with more than 20 people that presented 18 orals and 20 posters. So you can see the list of the conference. We started at Bremen in the first OSC with the dedicated sessions, and we have a dedicated session almost all the SCAR Open Science Conference. We reached the maximum of the audience during the Auckland conference with 50 abstracts, and also in Kuala Lumpur we were almost at the same size. I have to say that in the last Open Science Conference we reached probably the minimum of the activity, and also during the COVID period there was a decrease of the activities of the interaction for the group. ANTPAS obviously participated actively also to the International International Symposium of the Geological Sciences since the Edinburgh one, and also in that case in 2019 in Incheon in South Korea we reached the maximum of our participation. about the International Permafrost Conference that normally are held every 4 years. We had the sessions also last year in the last one, but above all, I wanted to underline that I am in charge of the next International Permafrost Conference that for the first time will be held in Italy, in Firenze in 2028. And so I want also to take the occasion now to invite you in this conference if you are interested and you are working on permafrost and the related topics. So our group is currently composed by around 130 people that are inscribed to our list. It's true that some of them are not still active, but I think that more than 100 are still active. And we cover 25 countries in all the continents. I just put here a couple of slides, very simple, to underline how is multidisciplinary or cross-disciplinary in reality ANTPAS. So for reasons that are related to the beginning, it was posed our expert group in the geoscience standing group, but in reality, the people that are working on permafrost in Antarctica are mainly focused on geology, as the number of the papers that you can find just looking to words like permafrost and Antarctica on a Web of Science are mainly on geology, but there are and physical geography, so climatic science. But there is almost all the same number of papers also on environmental science and above all on ecology, because the ice-free areas in Antarctica and in subantarctica are almost all covered by permafrost, and exactly as happened in the Arctic, permafrost people and permafrost topics are cross-disciplinary. About the papers in the time is interesting to see also that there are quite a lot of nations that are interested in this kind of topics, although the United States of America are the larger productive country, but you can see that there are more than 10 countries that are quite active on these topics. And above all, you can also see that the production of the papers it is increased a lot, especially after 2011. So which are the main topics of the group? You can see the list of these topics. Obviously, the first is measuring and monitoring the permafrost temperature, and also the second essential climatic variable recognized by the World Meteorological Organization, so the active layer thickness. But because our group was born very close to the soil organization, the International Soils Organization, also the monitoring of the soils development and the changes of these soils and also on the overlying vegetation is another topics quite well developed in several parts of the continent. Another kind of work that Stefano will explain better later are the identification, the analysis of all the landscape in the permafrost areas with several features like what you can see in the list, but also the finding and the monitoring of the impacts on the infrastructures and also on the ecosystems. The last topics that you can see in the list are quite a bit more recent and more peculiar, like the identification of the taliks and in general of the permafrost hydrology, and in particularly of the salty brines that there are in some taliks in the continental Antarctica. Also, the macrobiological analysis of some permafrost cores are quite interesting and important, also because represent one of the best Mars analog, and so are related to the analysis of the space. And the last one are the study of the weathering in the cryotic environment and the related features. That is another kind of topics that was born at the beginning of the permafrost research in Antarctica, and that in some sporadic ways is still going on, exactly like the analysis and the monitoring of the impacts on the coastal areas in permafrost areas. So I want just to put some of the main gaps that there are still in Antarctica, because regarding the permafrost monitoring, the network that we have is too small, and in some cases the protocols are not followed strictly by the researchers, and so the data are not completely reliable and comparable with the international ones. The impacts on the infrastructures in many cases are not considered. And also the permafrost hydrology is just at the beginning, in Antarctica at least. But above all, the two main, in my opinion, gaps are related to, not only to my opinion, but in general, are related to the subsea permafrost and the subglacial permafrost that are still not very well known. There are some researchers also that are looking now also the problem of the age of the permafrost, and if the permafrost core can be used as paleoclimate archive instead, or integrating what is possible to use through the ice core. So just a very brief situation of what during the ANTPAS activities we developed. In this map that is quite old because it's related to a publication of 2010, you can see with the red dots the deep boreholes that are now monitored, and I have to say that almost all are related to our research group. Only one borehole in the Beacon Valley and one in the Livingston Island are managed by other international research group. And I just put a couple of example of how are very different the permafrost envelope in places like Rotorua that is in the Antarctic Peninsula. So not in the Antarctic Peninsula, but is close to the Antarctic Peninsula, in which you can see that the permafrost temperature is around -4, against what happens in the dry valley, where the permafrost at the zero annual amplitude is very, very colder. around -18. So looking the more northern boreholes that we have, that is in Sydney Island, exactly at 60 degrees south, you can see that the temperature of the permafrost is around -4, also in this case, and it is much colder than what expected for this latitude, but this is related to the climatic condition, particularly of this island. And just to give one of the results that it was more cited because it's related to these network communication papers, you can see that almost all the boreholes in Antarctica are warming, except the Rotterdam one that is slightly cooling. So regarding the soils development, this is just an example of the results in the continental Antarctica, but you can find many, much more results. And it was possible to see that in only 10 years, the cryosoils that you can find also in continental Antarctica, they suffer a quite big strong alkalinization, and this was related also to the changes in vegetation that are all only changes in mosses and lichens species. So now, Stefano, if you wanted to go on.
Yes, Mauro, thank you. So in terms of the cryotic landscape in Antarctica, we present you some results, some publication we are publishing. So this is the first example about the atypical landform, a typical feature of this cryotic landscape that are frost blisters. So it was possible through remote sensing techniques, in particular drone, so UAV and terrestrial photogrammetry, to reconstruct the temporal change of this particular feature through the identification and comparison with a point cloud made in 2019 and the previous photographs of the old campaigns. Mauro, next. Thank you. So it was possible to reconstruct the difference in elevation of the top of these frost blisters in perennially frozen lakes. And the first graph can show you the series from 1996 to 2019 of the elevation of the ice level of the perennially frozen lakes and the two frost blisters presented in the lake. And this was possible also to correlate the elevation change of these features with the climatic variable that was the annual thawing degree day, TDD. So in few words, it is possible to see difference in the cryotic landscape governed, driven by a climatic variable. Next slide, please. Another example of the change of this cryotic landscape is what happened in 2019. So visiting a shore, a beach, permafrost beach, close to the Italian station, we realized that it was invaded by sea ice blocks. So it was a scientific question to understand when it happened and how much stronger was the ocean wave event to push these ice blocks into the shore. And once again, thanks to the remote sensing, in this case with a helicopter flight and photogrammetry, it was possible to reconstruct exactly at high resolution with good orthophotos the distribution of these sea ice blocks and also the features they developed after this oceanic wave event that I show you in the next slide, Mauro. with this map. So this is the one of the products of this survey that developed this high resolution geomorphological map of this area. So, for example, with different and peculiar, in this case, permafrost and shore features. And the next slide. And this is a peculiar and interesting topic because there are few research about how much the human impact can affect and can disturb permafrost landscapes. And this is one case close to the Italian station where there is one of the few ground-based runway, so constructed on a till, on a glacial till. And we noticed some problems related to this runway, this airstrip on its surface, as you can see on the left figure, with cracks and some thermokarst hollow. Mauro, next slide. So what we were able to do is to compare the thermal situation of the till, the glacial till, nearby the airstrip, and model the thermal properties of the airstrip. So thanks to the collection of temperature series with ground thermistor, the reconstruction with the satellite thermal sensor, and also a portable thermal camera, it was possible to model, thanks to the Stefan's equation, the active layer thickness, that is one of the essential climatic variable. And we model that inside the airstrip, it is kind of double of the respect to the TL1. So this construction of the airstrip impacted the active layer thickness, and so we are expecting to have more and more problems in the future. Thank you.
So thank you, Stefano. Just a few minutes about the more challenging and more recent topics about that ANTPAS and the people that are working together with us are approaching. So in particular, the question of the permafrost hydrology in some cases, like in the Dry Valley and also in close to our station, there are at least 3 cases in which through geophysical soundings it was demonstrated the presence of talik, so areas in which the water can be existing in liquid phase in permafrost that is very cold, and this is possible just because these liquids are strongly salty. This is the case, one of the 2 cases that we work in we discovered close to our station, the Italian station. In this case, there is a frost blister in a perennially frozen lake, and on this radiogram you can see that exactly below the frost mound there is an area in which the signal disappear, and through a drilling we discover below these brines that are several times more salty than the seawater. In another case, quite recently, we see that also with geophysics and drilling and chemical analysis, we discover that in these lakes, again, in frost blisters, we drilled and we found brines that are chemically very similar to what we discovered on these other boreholes and also in the glacier close to the base. And this is the schematic representation of the possible connections between these liquids. So about the subsea permafrost. There are a few works on this, and this is a schematic model of in which way in the Arctic normally the subsea permafrost can exist. And at least to my knowledge, at least in a couple of cases, so here at Rotterdam and also in close to Mario Zucchelli, we found, in this case, we found that the temperature of the rock is below 0 degree at least until more than 100 meters. And this means that is more than 70 meters below the current sea level. And because around the Rotterdam Point there are not large, but quite important areas that have the sea thickness less than 30 meters, there is the possibility to find the subsea permafrost, exactly like what we found also very close to Mario Zucchelli station. But obviously, in this case, this kind of analysis should be represented, should require bigger cooperation with also the scientists like Laura, for example, that working on the sea, and not only the people like me that we work on the land. Finally, we have the question, the open question of the subglacial permafrost, as probably you know, and also in this very old map that is one of the few that exist, there are several areas of below the ice sheets in which the base is frozen, and so that exists some permafrost. Obviously, the study of this is quite difficult, but it can be interesting also because the conditions and the dynamic of the ice sheet on a cold base is deeply different respect and not cold based. And just the last slide about that, this new analysis is a paper that is published a few months ago related to the possibility to use the permafrost or the cold ice closer to the permafrost for as a very old paleoclimatic indicators that was published on PNAS a few months ago. So I wanted to conclude here, remind you the next two meetings about ANTPAS. Even if this session of the next International Permafrost Regional Conference in Ulaanbaatar in 2026 is an Arctic session, was organized by our group, and we didn't define still now the exact dates, but next October's, thanks to the support of the Geoscience Standing Group, we will organize the second ANTPAS workshop in Varese. So thank you very much for the attention.
Thank you, Mauro and Stefano. Very interesting and a huge amount of work since many years. So thank you very much for your effort. If there is any question, now is the time for raising your hand or writing in the chat. There is one in the chat already from Roger, the leader of the Groundwater Action Group. So the two of you should talk more, I think, because there are many connections between the two action groups. I can see that. the groundwater is a newborn action group, so you have more history on the subject, but indeed there are connections. So Roger, are you there? You want to ask your question, or you want me to read in the chat? I don't know if you left already or if you're still there.
No, I'm still here.
Okay, fine.
Thank you for the very good overview presentation. Yeah, this was really, so this is not a question that has to be answered now. It's just really the Groundwater Action Group reaching out to ANTPAS. Because we at the moment have quite a few questions on simple schematizations of a groundwater model structure, and we particularly are suffering in that permafrost thickness space. So we could definitely use your help. You mentioned that there are still significant knowledge gaps of subsea and subglacial, but still you must know more about the topic than we do. So yes, as Laura is saying, I think we should probably talk sooner rather than later about the links between our group.
So thank you, Roger, because I have to admit that in the last 2 years I was not really active within the SCAR meetings, and so I didn't know that this new group is becoming the activity. And obviously, personally, but also our group in general, we are very interested in starting cooperation with you and your group. So my suggestion is just probably the easiest thing is if you can send me an email, I can answer, and we can start with a call between us, and then we can, if you think that it can be a good thing, we can establish a call enlarged to all the people of our groups that are interested, and make a kind of brainstorming or whatever regarding this topic that is you call groundwater, but in my case, in permafrost science, is normally considered, we use the word permafrost hydrology. But this topic is very important also in the Arctic, where it's still not very well known. And I have to say, because maybe you know, I'm the editor-in-chief of the main journal on permafrost, that is Permafrost and Periglacial Processes of Wiley. I have to say that in the last 2 years, we have a quite increase of interest regarding the permafrost hydrology in general. So I'm very happy that there are new people that wants to approach this kind of topic, and so I'm completely open to cooperate with you and with your group.
Thank you. Yeah, we'll set up a call. I'll send you an email. Thank you.
I have a question about one of your images that you show. If you can put your presentation back.
Okay.
One of the
moment
first
that I have to
slides.
share again. So
One of the first slides that Stefano was showing, I guess, these mounted features, this frost
blister, you mean?
blister. Yes, I think so. Yeah.
Okay, so maybe this one.
I don't see your presentation yet.
Because I share. So okay, now you can see.
It's coming, I think. Yes. These kind of mounted features could they be some sort of pingo-like features, or is something different?
Some people call them a pingo feature, but in Antarctica it's very difficult to find pingos, so they are small but basically the principle is the same. So the active layer is below the frost blister. So actually there is a push of liquid water from beneath that can uplift all the active layer and the sediment above it. So they can form like a pingo, so with a hydrostatic or hydraulic pressure of liquid water, yes, but they are not pingo.
So it's a question of terminology, Laura. So pingo are just bigger of size. In fact, in some papers, the same kind of feature like this are called the pingo-like feature. And the second difference, in addition to what Stefano said already, is the question of the age of these features. Because in this case, for example, exactly in this frost blister, we know the beginning of this process that was more than 1,000 years ago. And so in this sense, because it's quite permanent, we can also use in regarding the permanence the term pingo. Because normally in the Arctic, the frost blisters are seasonal or only a few years. Because Antarctic Antarctic permafrost is really different respect what you can find in the Arctic. In this case, in terms of age, we can correctly call pingo, but in terms of process is a frost blister.
Okay, so if you do some sort of geophysics across this, do you see what do you see? I mean, the acoustic phases is basically chaotic with no core inside, like the frost and blister is opaque acoustically.
So we
Just figuring because we see something similar on seismic at sea. So there might be completely different feature, but it's just
it
thinking.
depends. It depends from at which depth you can you saw your feature. But if you are interested now, we don't have the time, but we did ground probing radar with different antenna there. And we have also some electromagnetic data. And for example, below this frost blister that Stefano show, you can find a very high conductivity at more than 3 meters and a half of depth. That is the pool of brine, salty brines that you have below. But above you have a frozen ground that in terms of radar image is quite chaotic without any very nice reflector. In other situation, the radargram that I show in the other picture, when I talk about brine, you saw that there was below there was the good reflector of the sides of the frost blister because they were below the lake ice, and so there was a very big difference in permittivity. But within the body of the frost blister, you can't see almost anything. We never done seismic on this kind of feature. We did also electric tomography, and in that case, you can find very well that you have, I wanted to schematize a 3-layer, so a very thin layer, not really very resistive. That is the frozen ground above above some ice, because in some cases you can find some ice, massive ice below, and then there is the brines, so the liquid salty water. So, but it depends. Are not all the blister, the mounts are similar, because at least it depend. They depend also from the geology. Tara Flat, for example, that is the other one, in which there's no buried ice below the ground, but there is rock. The geophysical results are different. So it depends from singular case. But in any case, also, as we did in the very old past, if you remember, Laura, with the fin section that you sent to me, we can, if you want, we can see your results together. There's no problem.
Okay. I see there is a hand rising. Naomi, do you have a question?
Yes, if you don't mind. Thanks for a very interesting presentation. I work in the Canadian Arctic, so different region, but in one of your early slides, you had 888 papers on Antarctic permafrost in the Web of Science, and I was very interested in the topics. You had 221 papers that talked about agriculture, and I wondered what topics agriculture what do they do there that would be agriculture?
Yeah. I think that probably you know that this kind of so if you look through the the artificial intelligence, sometimes this intelligence is not so intelligent. So, but there are many papers that have these two keywords, Antarctica and permafrost, that regards the vegetation and the soil. But because probably I'm not an artificial intelligence, I'm just a person quite clever, but not so much. And I have to say that probably they put in this kind of classification soils, because in agriculture, soils is really important, and vegetation. But it's obvious that there's no agriculture in the permafrost areas of Antarctica. But if you should know that now there is quite a lot of agriculture in the Arctic permafrost.
Yeah.
So probably you know that one of the biggest cabbage that was produced in the world comes from Alaska. So it's quite interesting this. Now our association, the International Permafrost Association, start with a working group on the agriculture and permafrost.
Thank you. Thanks.
There is another question from Uday Sharma. I don't know if I pronounced correctly your name. You can ask your question if you like. We can hear you if you're speaking. No. Uday? Unable to unmute yourself. I'm sorry. Would you like to write in the chat your question? Okay, while something is showing up in the chat, I like to ask Stefano another question, if I can. When you were showing this the construction of this landing stripe, you were saying that it is impacting a lot the permafrost, the thickness of the permafrost layer. I didn't get how. I mean, it is
Mhm.
cooling down or is it warming up? It
It's
wasn't really
warming
clear
up.
to me.
So
Okay, so
apparently we have a slightly increase of the albedo on the surface because it's smooth and a little bit lighter, but on the opposite, you have a different grain size that is constant, so you don't have fine material. You have a very few, very limited water content compared to the surrounding glacial till. So if you put all these variables together, not only considering the albedo, and you check the ground surface temperature both with a thermal camera or a thermistor, you notice this difference. So you have a warming up of this surface, and this warming up with the thermal conductivity can go through into the ground, and so thawing permafrost and increasing the active layer.
also in the surroundings.
The surroundings, no, the surroundings is a natural trend of warming permafrost and active layer thickness, so driven by the climatic trend. But inside the structure, the runway, you have a totally different condition reworked by the human activity, and so you get this, let's say, faster thawing.
Okay, we got the question on the
Okay.
chat. As a new worker starting in permafrost research, what kind of care we can take while creating borehole so that we can have a minimum disturbance of subsurface, active layer, and permafrost stable?
Oh, so this is quite easy. It's important to follow the international protocols that I can summarize in 1 minute. So the first thing is to make the borehole not with liquids, but only with compressed air. So when you have to drill, you have to use compressed air instead of mud or water. Second is that you have to put inside a pipe that is a plastic pipe, and if it's possible, the thinnest plastic pipe that you have, instead that sometimes, unfortunately, for example, some of the deepest boreholes that there are in Antarctica that were held were done in the 70s were with the metallic pipe, and the metal conduct a lot of heat, and so it's not good. So you have to use plastic pipe. The third is that you have to construct um, the case, the upper case above the borehole, the smallest as you can, because you have not to change the snow condition. The snow can change very deeply the temperature. So these are the main important point. And as you probably saw in one of the slides that I show, it depends. If you wanted to monitor the active layer in Antarctica, you can do very shallow boreholes, just 1 meter or a maximum 2. But if you wanted to monitor the temperature of permafrost, you have at least you have to drill 30 meters. And the second question, how much grain size variation within active layer can affect the surface permafrost condition? A lot, but this is a thing that obviously you have to study and consider if you wanted to model the areal variation of the active layer, but it's not a question that you needed to know for just the monitoring.
Okay. So maybe you can again say a few words how if someone is interested in taking part of this action group, expert group actually, what's the best way? I mean, how can be involved?
Unfortunately, up to now, the best way is to send me an email, and I can add to the mailing list, and obviously to invite for the next meeting and so on. But in this moment, so since last year, we didn't have the permafrost, so the ANTPAS website, because until 2 years ago we did our own website for technical problems. Now is still not working. So and so also the email that we had in the past we didn't still have. So the easiest thing is to send me an email.
Okay. Are there any other questions? I don't see any hands on and no chat, nothing in the chat. So it's quite late in Italy, so I thank you very much for your kindness to share your time with us. And I also thank you everybody to be with us tonight. And we are recording. We have recorded the webinar, so you can still watch it later from the SCAR portal once we publish it on it. And yeah, SCAR is open to everybody, so anytime you are interested, you can send us an email and ask how you can be involved. And yeah, don't be shy. So we will see you again for the next webinar, which will be November 11 for PRAMSO, Paleoclimatic Records from Antarctic Margin and Southern Ocean, at 5 p.m. UTC from Carlotta Scuzia and Adrian Lopez. So I see you there, and I wish you good evening or good afternoon or good morning whenever you are. See you next time.
See you.
Thank you.
Bye.